Hello and welcome to my YouTube channel. In this video, I will introduce Grafcompounder 5.0, a software tool for predicting formulations for rubber, TPE, and other polymer materials. The goal with this software is to efficiently support polymer and rubber chemists in developing new materials. Here I provide a brief overview of the content of this presentation. We will take a look at development methods used in rubber industry, focusing especially on design of experiments and artificial intelligence, and conclude with a summary. Two key methods are in focus. First, the statistic experimental design technique, known as design of experiments, or DOE as its abbreviation. This method allows experiments to be systematically planned and statistically evaluated. Secondly, artificial intelligence. Here, existing data is used to make predictions and even simulate material properties. Both approaches help to significantly increase the efficiency of rubber development processes. This slide shows the prediction capabilities. Both artificial intelligence and DOE can be used to predict compound properties. In case of experimental design, predictions are limited to the experimental space with data generated through the experiments. In the case of artificial intelligence, predictions are limited only by the boundaries of the available data in the database. This significantly reduces the number of necessary real experiments. This slide introduces the fundamental differences between artificial intelligence and design of experiments. Artificial intelligence analyzes medium to very large databases that have been collected over many years. However, AI does not work automatically. It requires a clearly defined model. In other words, the developer must decide which properties are important and what should be optimized. Design of experiment follows a different approach. It generates structured data through carefully planned experiments and uses regression analysis to describe the relationships between formulation and material properties. Both methods pursue the same objective, predicting the best formulation. They simply reach that objective in different ways. Both artificial intelligence and design of experiments rely on mathematical algorithms. These algorithms analyze complex relationships between ingredients, processing conditions, and material properties. The mathematics behind them may be sophisticated, but Grafcompounder performs these calculations automatically. As a result, developers can focus on engineering decisions instead of mathematical calculations. A major advantage of artificial intelligence is the ability to use historical industrial data. In the past, data were collected over many years using different development methods, different testing procedures, and different storage systems. As a result, these databases are often heterogeneous and incomplete. Grafcompounder helps organize and analyze this valuable historical data, transforming existing engineering experience into useful knowledge for future developments. Reliable predictions always depend on reliable data. Before using a historical database, its quality should be evaluated. Outliers can be identified and removed. Ingredient property relationships can be analyzed, and correlations between different properties can be verified. Improving data quality directly improves prediction quality. Artificial intelligence and design of experiments should not be seen as competing technologies. They complement each other. Artificial intelligence makes use of existing knowledge by exploring historical databases and identifying promising formulations. Design of experiments is then used to confirm these predictions, investigate new materials, and validate the final solution experimentally. Together, they create a faster, smarter, and more efficient development process. This concludes our introduction to Grafcompounder 5.0. As you've seen, with a Grafcompounder you can combine artificial intelligence with design of experiments and practical engineering knowledge to accelerate compound development and improve prediction quality. In the next video, we'll take a closer look at how Grafcompounder works and how artificial intelligence predicts optimized formulations from historical data. From practice for practice, building the hybrid future of rubber compounding. Thank you for watching, and I look forward to seeing you in the next video.